In this video, we are going to see a brief introduction on electric charges and electric fields. First, let's go over some basics. We know that atoms make up everything in the world. Atoms are the building blocks of matter. And atoms are made of three subatomic particles: protons, electrons, and neutrons. And protons are positively charged, electrons are negatively charged, and neutrons have no charge, they are neutral. We know the arrangement of protons and electrons. Protons and neutrons are packed here in the nucleus, where electrons move freely around the nucleus. So from the arrangement of the subatomic particles, we can see that it is easy for the electrons to leave the atom because they are at the outer layer. So that's why we have already seen that only electrons or the negative charge can move. So it is easier to add electrons to an atom or to remove electrons from an atom. Electric charge is created when an atom loses or gains electrons. We know that atoms in general are neutral because they have equal number of protons and electrons or equal number of positive and negative charges. So atom by itself has no charge or neutral. So when a neutral atom loses electrons, it becomes positively charged. So when electrons are lost, it becomes positively charged because it will have more protons. So the resultant charge of that atom becomes positive. So when an atom gains electrons, it receives more electrons, so it becomes negatively charged. So this is how charge gets created when an atom loses or gains electrons. Charge is measured in coulombs. So coulombs is the standard unit of measurement of charge. It is denoted by a capital C. How big is this coulomb? We know that electrons are negatively charged, so it has a tiny amount of electric charge. So every electron has an average charge of negative 1.6 times 10 to the power negative 19 coulombs. We can imagine negative 19 is such a tiny number, such a small number. So to make 1 coulomb, it takes about 6 million electrons. So that's how tiny the charge is attached to the electron. And this also tells us the charge of a proton. So charge of 1 proton is positive 1.6 times 10 to the power negative 19 coulombs. How do we know this? Because the charge of electron and proton must be equal and opposite. 1 coulomb is relatively a large charge. So often we use microcoulombs to measure charges. We know that micro something means 10 to the power negative 6. So 1 microcoulomb is 10 to the power negative 6 coulomb, or 1 coulomb is a million microcoulombs. For example, when you rub a plastic rod with a cotton towel, the rod gets charged, right? The charge possessed by that rod is 0.005 microcoulomb. That's how big a coulomb is. Do not worry, this is only for you to understand the intensity of 1 coulomb. All you need to remember is the unit of measurement for charge is coulombs. How do charges interact with each other? When two or more charges are placed next to each other, how do they interact? We know that like charges repel and opposite charges attract. So when two like charges are placed next to each other, they move away from each other, they repel. When two opposite charges are kept next to each other, they attract. So we need to know this to understand how charges behave. Electric field. Electric field is the region around a charge. So when there exists a charge, it has an electric field around it. The charge exerts a force on objects placed in the electric field. So electric field is the region around the charge where the force exerted by the charge can be felt. An electric field is represented by electric field lines like this, and the arrows indicate the direction of the force on a positive charge placed in that field. What does this mean? See, the arrow direction should have a convention to follow, should have a rule. For example, our magnetic field lines always go from north to south. So similarly, the rule for drawing the arrows for electric field is that when you place a positive charge in that field, what force is exerted on the positive charge? That decides the direction of the field lines. Now read this again. Arrows shows the direction of the force on a positive charge placed in the field. So if a positive charge is placed in this field, this will push that away. So that's why we have a outward arrow around positive charges. And if a positive charge is placed here, the negative charge will pull it towards itself. That's why we have an inward arrow around negative charges. So the arrows shows the direction of the force on a positive charge placed in the field. The spacing between the field lines indicate the strength. So the closer the lines are, stronger the force exerted. So if an object is placed here, it experiences more force than an object that's placed here. The spacing between the lines indicate the strength. So force of attraction is stronger closer to the charge. And all electric charges have an electric field around them. Combined electric fields. So combined electric field is a combination of two or more fields when they are close to each other. When there are two or more charges close to each other, the individual electric fields are combined, they get altered, and this is how it looks. If you have a positive and negative charge next to each other, they combine and the electric field looks like this. And when you have two like charges, they try to repel, so the electric field gets altered and it looks like this. So these are the basic information that we need to know. Now I hope you have a good understanding of electric charges and electric fields. Thanks for watching.